In this video, we are going to look at covalent bonding. In our previous videos, we had just finished ionic bonding, having looked at its properties. However, with this type of bonding, please take note of the spelling. It's not spelled as covalent. So we don't have an N here. So let's dive deep and see what it's all about. So when you look at a chemical bond, it's basically a force that keeps atoms together. But for covalent bonding, we shall always be dealing with sharing of electrons. And in this case, we shall always be considering the outermost electrons, the electrons that are in the outermost energy level. So whenever a chemical bond is formed by sharing of electrons between two atoms, we shall always call it covalent bonding. And just like in ionic bonding, the compounds containing covalent bonds, we shall always call them covalent compounds. Just add covalent to compounds, then you have covalent compounds. So a covalent bond is formed when both reacting atoms need, take note of this, electrons to achieve an inert gas electronic configuration. So remember, for an atom to have an inert gas electronic configuration, it must have a fully filled outermost energy level. And in this case, we shall realize that some atoms will always prefer to gain so that they obtain all the maximum number of electrons instead of losing them. So in covalent bond, we shall only be dealing with atoms that need electrons to become stable. And in this case, these atoms will be the non-metallic atoms, non-metals. So ionic bonding, we saw transfer of electrons, but for covalent bonding, we shall always need the sharing of electrons because both atoms will prefer having more electrons added to them. By now, probably you might have an idea that nonmetals usually have 5, 6, 7 electrons in their last or outermost energy level. And because of that, usually to attain stability, they will always need electrons. So in most cases, whenever they are forming ions, they will prefer to gain electrons. However, when you have two nonmetals coming together and they both prefer gaining electrons, the best they can do is by sharing, mutual sharing of electrons, because none of those atoms will prefer losing, yet both of them want to gain electrons. So the best they can do is to share electrons. So whenever a nonmetal combines with another nonmetal, both needing electrons, a covalent bond will always be formed. Let's take a look at the following nonmetals. We have oxygen. You realize that oxygen has 1, 2, 3, 4, 5, 6 electrons. It has 6 electrons in the outermost energy level, and it needs more too, so that it can have a maximum of 8 in the outermost energy level. When you look at nitrogen, 1, 2, 3, 4, 5. Nitrogen has 5 electrons, and with that it will need 3 so that it also gains and obtain a maximum of 8 electrons. So as you can see, all these nonmetals actually prefer gaining because losing will be much more difficult. And lastly, when you look at chlorine, it has 1, 2, 3, 4, 5, 6, and 7. So chlorine has electronic configuration 287, and it will need one more electron to become stable. And in this case, if chlorine comes into contact with other nonmetals, the best they can do is to share, because none of these atoms will be willing to lose electrons. So the best they can do is to share. So before we look at the process or the formation of covalent bond, we need to first have some examples of the covalent compounds that we might encounter in our day-to-day chemistry. When you look at the first example, we have methane, CH4, and the elements present, we have carbon and hydrogen. Remember, carbon and hydrogen, these are nonmetals, although hydrogen has its own issues. When you look at ethane, 2 carbon atoms and 6 hydrogen atoms, they are also nonmetals. So one thing you realize is that most of these organic compounds from methane, ethane, ethene, and ethine, all these are covalent, and you'll realize they're actually gases. Remember, in our ionic compounds, we basically had solids. We go to ammonia. Ammonia, we have nitrogen and hydrogen. They are also nonmetals, so they will share. We have our alcohol, ethanol. This is also a covalent compound. This is a liquid. We have hydrogen sulfide, is a gas, carbon dioxide gas, carbon sulfide, and so on. So one thing to note, most of these covalent compounds are gases. So we shall see under the properties of covalent compounds what state are these covalent compounds in most cases. So these are some of the examples. You can maybe name some more compounds like water and so on, but these are some of the common covalent compounds. Lastly, we still have 4 more examples. We have carbon tetrachloride. This is a colorless and highly toxic liquid. Basically, we have our carbon and 4 chlorine atoms attached to it. We also have glucose, one of the main building blocks for starch and other carbohydrates. We have cane sugar, basically sugar found in sugar canes. And then lastly, we have urea, a chief nitrogenous end product of the metabolic breakdown of proteins in all mammals. It contains nitrogen and is also soluble in water. All these examples are covalent compounds. Finally, we come towards the end of our video and we have our top 3 questions. Number 1, what do you mean by a covalent bond? We shall look at a detailed explanation of covalent bonding when you look at the formation of a covalent bond in our next video, but probably at this point you should be having an idea on what a covalent bond means. Number 2, when a dash combines with another dash, a covalent bond is formed. And lastly, number 3, choose the covalent compounds. We have methane, hydrogen sulfide, and carbon disulfide. Then lastly, all of these. Which of these objectives do you think is the covalent compound or a covalent compound? Thanks for watching, and if you find these videos helpful, don't forget to like, share, comment, or subscribe so that you're always notified whenever I upload any new videos. In our next video, we shall have a look at the formation of covalent bond. We shall need to see how these nonmetals share electrons to form a bond and how this bond keeps intact so that these atoms don't pull apart. Thanks for watching. Be well.